Hi all, welcome to part 5 of the video lecture on physical data organization. So in part 4 we discussed about that hash file organization, the basic hashing technique and how different um, how they are dealing with the collision and different approaches for collision is what we discussed in the previous video. Now let's continue our discussion so the type of hashing technique that we discussed so far is what we call as static hashing in the sense so they are not flexible for dynamic file expansion or shrinking. Okay, so something like that we will take an example and we will see how this static as well as dynamic approaches are varying. So for the time being the type why we call those technique that we discussed so far as static in the sense we are typically having a hash table, right, and the size of the hash table is fixed and there is no way to um, dynamically change the size. Okay, so something like that. So is there any alternative ways? That is what we are looking here. So the hashing scheme described so far is what we call as static hashing because a fixed number of buckets is allocated in the secondary memory, right? So particularly that external hashing, you can see the buckets are being allocated and that is fixed for a given file. So the function um, so what I want to tell you, the fixed number of buckets are allocated in the second memory. The function does a key to address mapping. You can see, so we have a hash field or hash key, and that will be mapped using a hash function, and that will give a hash address corresponding to the hash key. So now this can be a serious drawback when it comes to dynamic file in the sense dynamically on the go the file size can increase or decrease and that is not in our control. Okay, so that kind of application, think about such an application where this is not going to work. Suppose that we allocate say m buckets in a fixed manner for the address space and let m be the maximum number of record a particular bucket can hold. Bucket is that unit, hope you remember, it can be a single block or a collection of blocks, and the maximum number of records in a particular bucket, let it be this that small m. So that total file size could be something like a m into capital M. Okay, so this is something fixed. So for the time being the number of records is much less than that. Most of the space that you allocated will be wasted, and although and at the same time if the file size is something more than this, if the number of records in the file is something more than this, it's not going to support, right? So if the number of records turns out to be substantially fewer than this value, we are left out with a lot of unused space. Okay, so dynamic shrinking of the file is not supported by this static hashing. And on other hand, if the number of records increases substantially, say more than this value, numerous collisions will occur, and we can increase larger file size with the help of that overflow block as well as that collision resolution technique like chaining or something, but that is going to add some extra effort when it comes to searching an information. Okay, yeah, that would. So in either case, we have to change the number of buckets m allocated in some dynamic way. So that is the whole intention. So we can think about dynamic file expansion as well as shrinking. Okay, so a major drawback of the static hashing scheme that is being explained so far is that the hash address space is something fixed. Okay, so this is what we want to resolve. Hence, it is difficult to expand as well as shrink the file dynamically. So, the first scheme to remedy this situation is something known as extendable hashing. And see, this is what is directly given in your syllabus, and you are supposed to study only this technique. And there are other approaches also like linear hashing and this dynamic hashing. These are all different other approaches that are being put forward for making this for supporting this dynamic file expansion. So, but we will look in detail this extendable hashing. So that is what is needed. So here what we are doing is we are going to store an additional access structure. So access structure in the sense this in some kind of index table we will maintain. Anyway, we will see that indexing in detail in the subsequent set of videos. So we will see. Okay, so it is not same as indexing scheme. Because here we are using hashing plus indexing, something like that. Indexing is slightly different. Okay, anyway, we will understand this extendable hashing technique as something new without any relation with the indexing, because we are going to see that topic only. Okay, so that about it. In it is being proposed by Fagin in 1979, and here we are using something like a directory, we will see that, which is an array of 2 raised to d buckets, and where this d is known to be the local sorry, global depth of the directory. Okay, we will understand that. So it is something like this. We are maintaining a directory, and this directory is actually something like our index table. So that is why, so it is something, so this is our original file being mapped into hash table, and in addition to this hash table, I mean a collection of buckets, we are maintaining something like this directory. So this is some additional access structure to this actual hash table. Okay, something like that. And in that directory, how many entries are there? In this particular example, there are 8 entries, right? So there are 8 entries. 8 in the sense 2 power 3, that is equal to 8 entries are there. And what is this 3? This 3 is known to be the global depth. So in general, if you are having in general some 2 raised to d entries, you can call this d as the global depth. Okay, so here it is just a 3, fine. So that about it. So keep that in mind. We will understand everything clearly. Now let me just tell you what is happening actually. So this is where the actual file records are supposed to place. Okay, so here you can see the data file inside buckets and all. And now look at this particular record. You know, there are different attributes, and out of them, one of the attribute we will select as the hashing attribute or hash field or hash key, if it is a key also. And to that hash key, suppose I am going to apply that hashing with respect to this particular attribute or some other attribute. Okay, so this is my hash key. Okay, so what I will be doing is I will apply a hash function. It can be on that hash key. So something like say k mode, say number of buckets, and something like that, where n is a number of buckets. Okay, I'm just taking an example on possible hashing function you can apply. You can think about other hashing function also. Anyway, we have a key attribute, and to that we are applying the hash function. Some hash function you will apply, and this is going to give you some hash address. Okay, so the result of this is going to be a hash address. And a hash address in the sense, when you take that mod, and you will get a remainder after division, right, with this n, and that remainder is going to be your hash address, and which is a number, some decimal value, right, you are getting, and you write that a particular integer. So as you if you are taking mod, definitely you will get an integer as the remainder after division, and you write it in bits. So what I am trying to say is, suppose this hash address is some k bits. Okay, so k is already taken. So this hash address is having some sequence of bits. Okay, out of them, the most significant 3 bits. So when you write that hash address in binary, okay, focus on more significant 3 bits of the hash address in binary. So when you focus that more significant 3 bits of the hash address in binary, you know, you are just looking at 3 bits, you will get any of the 8 combinations listed. Like it can be 0, 0, 0. So you got it, right? So apply that hash function, you will get a hash address. I mean hash mapping, some value you will get. So as it is mod function, definitely you are going to get a integer. You can write that integer in binary, and when you are writing it in binary, you will be you may get some x number of bits, and out of that they just focus on the most significant d bits. And what is that d? It is the global depth for this approach. Okay, so for the time being, just define it as just give it the name global depth. We will understand its impact everything soon. Okay, so that is our 3 bits. So it can be any value within this range, and for go to that entry. So just like an array, if you are getting like a 0, 1, 0, go to that a of 2, like that, and you will get a pointer, right? And now you can see that this pointer is pointing to a block, and in that, not a block, this pointer is pointing to a bucket. Okay, so suppose you are getting it as 0, 0, 0, this is going to focus on this bucket. If you are getting something like this, it is going to focus on this bucket. Okay, similarly this entry is focusing on this bucket, and this entry is also focusing on this bucket. So that can happen, so that we don't know. Okay, So what we done is like corresponding to each directory entry you can see a bucket here, but it is not like that. Here there are 8 directory entries, but here we have only 6 buckets. In the sense, here you can observe that for this particular entry, just trace this pointer, and also for this particular entry you can see a single bucket in the sense both of them are pointing to this. So we will see why it is so. Similarly, these two entries are also merged, like here both of them are pointing to this. Fine. And for others we have a unique bucket for that. So it is, there is no requirement that the number of buckets and the number of entries in the directory are to be same. It can be different also, like this. Okay, now what we will do in this particular example, so you do like that. So hope you understand that I am removing this. You just look at the most significant 3 bits of the hash address and trace that pointer, and in that bucket wherever you are having space, and there you don't have to maintain any ordering. If you want, you can maintain keep the records in order within a bucket also. That will make future, I mean when you are searching within a bucket and all, you can do in some kind of what called binary search and all. So that is up to you, but for the time being we are not maintaining any such ordering. So what we will do is we will simply insert that particular new record at the end of the particular bucket. Now there are different situations, like sometimes you can think about something like there is no space in the bucket. It can happen, right? So what you will do? So these are all the situations we are going to deal with. Now before that, let me just tell you why these 2 pointers are pointing to this single bucket. So it is something like this. So if you are looking at this 010 and 011, there are records with the most significant 3 bits are 010, and also there are records with the most significant 3 bits after applying hash function as 011. So now both of them are getting mapped into a single bucket, and there is a terminology called local depth, and the local depth for this bucket is defined to be 2, in the sense some are having more significant bit as 010 and some are having more significant bit as 011, and out of them the most significant 2 bits are same, and this is varying. So this 01 is going to identify this particular bucket, in the sense whether the most significant 2 bits are 01. If it is 010, 011, it is happening. Both will be mapped into this particular bucket. So this is because the situation is like the number of records having the most significant 3 bits as 010 as well as 011 are relatively less. So we don't need separate buckets for them, and both records, the 010 and 011 can be accommodated in a single bucket, because such queries are relatively less. Such entries are relatively less. Okay, so this is when the requirement is happening on the go. When it is needed only, you will allocate buckets and all. Beginning you may allocate one bucket for two entries, or may for 4 entries, like that, and on the way if it is needed you may allocate more. So that is how dynamically this file expansion as well as shrinking is handled. Okay, so here it is a particular instance, and the observation is that both the set of records having the most significant 3 bits of 010 and 011 can fit into a single bucket, and that is why we are keeping it like this. Yes, now the thing is that so that is how you are dealing with the global depth as well as local depth. So global depth and local depth are normally found to be same, so that means I have a separate entry for each and every directory. Okay, I mean I have a separate bucket for each and every directory entry. So here for the first entry I have a separate bucket, so that global depth and local depth both are 3, right? Similarly for the second directory entry also I have a separate bucket, so both are same, right? But for the third one and fourth one together, I just have a, right, I just want you to notice this. So for this one and this one together I just have a single bucket. Okay, so single bucket in the sense, now you can see like all records having the prefix bits as 010 and 011 will be moving here. And now I can say that any record within this bucket is having the most significant 2 bits are 01. Okay, most significant 2 bits are 01. So that is fixed. But I can't say anything about the last bit when I am looking at this particular record. Okay, so that is the case. So why I have a situation like that? Because the number of records with this prefix is relatively less. So that's why I am using a single bucket for that. And here and all it may be sufficient. Here also the same thing is happening. Okay, and the last two separate. Now let's see what we will do when there is overflow. So let me first explain the situation when there is overflow for a bucket. whose local depth is smaller than global depth. And you know, this is a situation where a single bucket is being allocated for more number of directory entry. So because such records are relatively less. Now dynamically on the go, what happened is a few more such records started added into the database table. Okay, so that can happen, right? So for example, uh, those with the prefix are 010 as well as 011, right? These two, I'm maintaining this. Now what happened is this particular bucket, anyway size of a bucket is fixed, right? It is filled at a particular point and there is a new record coming and there is no space for it. Its prefix can be 010 or 011. And this is a situation where you can't handle that particular record. You don't have space within this bucket and you are not supposed to put it in some other buckets also. So what you can do is, you can, at this point, you can split this particular bucket. Okay, you can split this bucket. You can split this bucket in the sense, in the secondary memory. So these are all memory spaces, right? You can do like, you can in some another sequence of memory you allocate as a new bucket, and what you are going to do is let this bucket be identified with the prefix that is 010 and let this be identified with the prefix 011, something like that. Okay, so that its local depth will increase to 3 and its local depth is also going to be 3. Okay, just increased. Now what you will do, there are, this bucket is currently filled, right? So you are having those records with 010 as a prefix as well as 011 as a prefix is right now in this bucket, and from that you will separate all records with the 011 as a prefix into this one. Okay, and those records with the 010 as a prefix you will keep here, maybe in continuous location, you may shift and all. Okay, so now you understood, right? So now it is slightly like the original record bucket is being spread across two buckets. The second one is newly allotted. So that those with the prefix 010 will come to the first bucket and those with the prefix 011 will come to the newly allocated bucket. And now you just adjust the pointer, like this first pointer, let it point here. Now the second pointer, you know, that is 011. Okay, don't do like this, you put it here, something like this. You got it, right? So this pointer is now going to store the address of this particular bucket. So like that you can handle. So hope you understand how you are dealing with the, some kind of overflow situation when the local depth is smaller than the global depth. And that is a situation, initially we were having a single bucket for 2 directory entry. Now that once that bucket started overflowing, this particular bucket started overflowing and I am going to allocate 2 buckets for it. So that's all. So now this is straightforward and it is very clear. And similarly, at any point if you want, you can, just like this splitting, you can do merging also. For example, the last 2 buckets, so that is with the, see, for this one I have a separate bucket, this one also I have a separate bucket, that is this one and this one, right? At any point you may feel like the number of records in that last 2 buckets are relatively very small. Maybe you can fix some threshold and all, maybe if it is less than half fill, something like that. If you want, you can merge these two into a single bucket also, and you can set that local entry, local depth d dash as 2, and both of them will move into, so that you can make that extra space free. Otherwise in those 2 buckets separately have extra space. Now when I'm moving all the records from the second one to the first one, making continuous location, I can make as free, right? So something like that you can achieve. So this will happen dynamically. So this is one thing. Now the second thing is what you are going to deal with, what you are going to do when there is an insertion into a bucket, something like this first bucket or the second bucket, and it is already overflow. It is already filled. So for example, suppose I have a record with the prefix as 001, this one. And when you are coming to this particular bucket, assume that it can accommodate some 3 or some records, all are occupied for the time and there is no space in it. Now, can you allocate a new bucket for it? And you can reset the pointer like what you done here. If you are going to allocate a new bucket, the difficulty is like now for a single directory entry like a 001, I am having 2 buckets. But previously for 2 entries I am having 1 bucket, and when I allocated new one, I just adjust the pointer, that is enough for me. But now what you are going to do, or how you are going to differentiate the record, the only option left with you is like the prefix is now 001, right? Now you so for this one also prefix is 001. So as there is no space in it, I am going to allocate a new bucket. So what I am going to do is I am taking the help of the fourth bit also. So those records with the 0010 as the most significant 4 bit I will be keeping in this record, and those with the most significant 4 bits I am just taking the help of one more bit. 0011 will be moved to that new record, and accordingly look at take the new record for which you find that overflow issue, and look at the most significant 4 bit. It will be 0010 and 0011. Accordingly you move to the any of this bucket. Now there is a difficulty, like in the directory I have an entry corresponding to 001. So in a single entry you can't maintain 2 pointer, right? That is meaningless. So what I'm going to do at this point is I'm going to maintain this single entry. I'm just splitting into 2, right? The first entry will correspond to 0010 and the second entry will correspond to 0011. Hope you get it, right? Something like that. But I can't simply split a single entry. The only thing you can do, so now the directory is being identified with 4 bits instead of 3 bits, okay? But for other entries it is just 3 bits only, but the requirement is happening only for that 001, that case. But still we are forced to increase the global depth by 1, right? Now accordingly you change the directory completely. So what you have to do is, now the directory itself is going to be of double size. So every entry you are going to split, like now there are 8 entries, so it is going to be doubled, in the sense it is going to be 16 entry, something like this. There will be 16 entry, and the first entry will be identified by 000, 00001, like that. There will be 1111. This many entries will be there. And when it comes to these two entry, like 0010 and 0011, and they will be pointing correctly, and this 0010 will be pointing here. So this will be pointing to this, okay. Now what about others? For example, for 000, right now I have a single bucket, but after doubling the directory, or after splitting that single entry into 2, I am getting 0000 as well as 0001 corresponding to 000 as a prefix, okay. Now both of them will be pointing to this one. Something like what happened in that case, like global depth as 3 and local depth as 2. Here it is global depth as 4 and local depth is 3. Okay, so that kind of a situation will occur. So hope you get it, right? So this is something, I mean, I'm just removing these things. So just for explaining the concept, I written all those things. So what I was trying to say, hope it is clear. So when it comes to the overflow situation in a bucket whose global depth and local depth both are same, if local depth is smaller, it is very straightforward. Just allocate a new bucket and adjust the pointer and move the records. That's all. But if both are same, allocating a new bucket is fine. But how you will deal with the directory? So directory is also going to be doubled, in the sense all entries are somehow splitted, like that. Okay, and accordingly you are adjusting all the pointers. So for example, 0010 will be a new bucket, 0011 will be the newly allocated bucket. And what about others? We are not going to allocate new buckets for others. Simply we will adjust the pointer, like 000 is going to be split into 0000 and 00001. I mean for 30 followed by a 0 as well as 3 zeros followed by 1, and both of them will point to the first bucket. Similarly other entries also. Okay, so this is how you are dealing. So now rest of the cases for some very good period of time are following this kind of a directory as double. So now the directory is getting doubled, in the sense now you are able to handle all. I mean you can support up to some 16 buckets. So for the time being there is only 6 buckets, and maybe when there is a problem with that overflow for that 001 that particular bucket, you allocated one more. But similarly you can keep allocating, and you can go for some 16 bucket. Till that there will be no issue like this, and after that you may, if the file size increases still, right now the we can support the file 2 times of the file size also, the original file size also, because corresponding to each directory now there are 2 entry, in the sense you can allocate 2 buckets as I mean whenever it is needed. Okay, you can allocate you can double everywhere, like the, so finally you can go for a double file size of the current one. Okay, so that is the thing. And maybe the current file is of some 1024k or something, it can go up to some 2048k, and if you want it to be doubled further, if you want to increase the size further, there is still option that 8, now this 8 entry is doubled into 16 entry, and after some time if you want you can double that 16 entry into 32 entry. So like that you can support both expansion of the files as well as shrinking of the file. When it comes to shrinking, we will just adjust the pointer and we will remove one of the bucket, and both bucket entry you will keep in a single bucket. See, at any point, whether it is insertion into an into a bucket which is already full, or in the case of deletion and which is going to make a bucket less filled, number of records in the bucket is very less. In all those cases, you are doing some adjustment, at most 2 buckets. Okay, this, so when you are allocating a new bucket, so just move or half of the bucket, half, or those record with the prefix like a 00, it was 001 case, 0011 into this, that's all. And you are not disturbing any other bucket, so the amount of time you have to spend on this adjustment and all, just when you are doubling the size of the directory, you may spend some time, but that is once in a while only it is going to happen. In all other cases, some few pointer adjustment and as well as some few record copying is what is involved. So it is not a huge time consuming process, and at the same time it can dynamically, so it's supporting the dynamic increase of file size as well as file shrinking, both are supported. Hope you understand, right? So at any time you can double the file size as and when needed. Yeah, now just read it. So hope you understand what is the impact of that global depth. The meaning is like the integer value corresponding to the first order d bits of the hash value. After apply hash value, you will get an address on that index, is used as an index into the directory, which is an array. Okay, and the address in that entry determines a bucket where that record can be stored. However, there does not have a distinct bucket for each of the 2 raised to d. So there are 8 entry, but there is no 8 buckets, right? So only 6 buckets. So depending on need, you will be allocating the bucket. So there is another thing maintained, what I can say is the local depth. This is d dash, right? The local depth. So that indicates if the local depth is small than global depth, it says that the number of records having that prefix is relatively less. So instead of allocating 2 buckets or 4 buckets, I am just allocating 1 bucket. See, this you can extend for here. This difference is something like 3 and 2. Just one difference is there. Sometimes this difference may be here it may be 4 and here it may be 2. That can also happen. So that means 4 entries are now merged into a single bucket. Okay, so all the records with the 4 different prefixes are going to be mapped into a single bucket, or 8 entry can be mapped. So like that can vary. Okay, so on demand only new buckets will be allocated, so that you have to be careful. And when this d is getting changed, you can see that at any time this global depth can change just by 1. And let me tell you one more situation where this global depth can decrease, in the sense that global depth d can change it to 2. So let me tell you the situation like there are 8 directory entries, something like this, but there is only 4 buckets. So can you tell me what is the situation? There is only 4 bucket, in the sense every 2 entries of the original directory is now merged and mapped to a single bucket. Okay, that means there is only few file records available. So that is the reason I don't need a separate bucket for each and every directory entry. 2 entries will fit into a single bucket easily. Now why we have to maintain such a bigger directory? Okay, so just there is only 4 buckets, right? So simply in the sense both the 000 and 001 will be mapped to one bucket, and this will be mapped to one bucket, this will be mapped to one bucket. So you just reduce the directory also, these two entry you merge and identify just using the first 2 bits. Okay, now the directory will be something like 4 entries will be there, 00, 01, 10, 11. And actually these 2 entries, the situation where these 2 are merged. Now instead of that, this will be pointing to that. Okay, so hope you get it. So like that, the global depth can increase as well as decrease. So the global depth size is decreasing like from 3 to 2, in the sense the file size is very small, and it's we are just allocating 1 bucket for every 2 pair of directory entries. So instead of that, I just reduce the directory size, so from 8 to 4, so that the global depth reduced to 2. And the other situation is the file size is dynamically increasing, and that time it is not possible for you to keep all records having say prefix 000 into a single bucket, and that time you are allocating, you are in need of one more bit to identify it, something like that, because 2 buckets having prefix as 000 and the fourth bit I will use. to differentiate them, and accordingly the directory size will be doubled. Okay, so it is supporting both. So the value of d can be increased or decreased by 1 at a time. So at any time this is going to be increased or decreased by 1 bit only, and this doubling on the background, what is happening, doubling as well as having the size, the directory entries. Okay, and you can see the doubling is happening when d dash is equal to d and it overflows. See, this is important. So you understood, like doubling in the sense this 8 entries double to 16. That is happened when this d dash and d both are 3 3, right, and there is overflow in this. Okay, and similarly having I mean it's getting reduced by half. That is going to happen when d greater than d dash, something like this 3 and 2, d greater than d dash, and that is the case with all buckets. Okay, so here it is not going to happen because here and all, so I just want this d strictly greater than d dash for all the buckets. So here also I want to be merged, so that it will be 2. This also I want to be merged. Okay, so that 2 blocks. Okay, that's also the most record retrieval. So how many block access are needed? One block access you need in the directory and another block access you need in the bucket. So buckets are typically one block, or it may be more than one block also. And bucket splitting also I explained. So hope you remember. You can just go through it in the situation. One is something like you are going to that 0 1 case, right? So hope you remember. So here it is 0 1 as well as 0 1 0 0 1 1, both are coming to this, and there is no space in this bucket, and that time you will allocate a new bucket, and you will move the records and just you adjust the pointer. There is no directory entry size change and all. Okay, so that you just read it. And the second case is like both the global depth and local depth are same. So this local depth d dash and global depth both are equal, and there is overflow. Okay, so I just have to depend on one more extra bit, so that the global depth becomes 4 as well as local depth becomes 4 only for those buckets. Okay, and that is a situation the directory size is doubled. Yeah, that about it. Hope you understand how this particular concept is dealing with the dynamic file size increase as well as decrease. So the advantages are obvious in the sense like definitely it can support dynamic file expansion as well as shrinking. That's the main advantage. Make it attractive is that the performance of the file does not degrade as the file grows. Okay, so you can grow the file size without degrading the performance in the sense the access time, right? So we are not compromising the access time. So just like the normal static hashing, in the sense you are getting all benefits of hashing, at the same time the file size is also dynamically changed. Okay, so that about it. So where collisions increase and the corresponding chaining effectiveness. But when it comes to static hashing, if you want to increase the file size, definitely that chaining will happen on the background, and that is going to degrade the performance of the file access, because that chain, tracing that chain is time consuming, right? Yeah, that about. So additionally, there is no space is allocated in extendable hashing for future growth. So on demand only that extra space is allocated. Hope you notice that also. Additional buckets can be allocated dynamically as and when needed. And the space overhead, and one negative side you can think about is that extra directory, right? The space taken by the directory, but it is negligible, right? It's a very small thing. Just that pointers only we are keeping there. So that is negligible. It is fine for us. And you know that d bits is the most significant prefix. I mean the prefix d bits you are observing. Maximum that address is of some k bits, right? So that can go up to some 2 power k instead of 2 raised to d. So right. Another advantage is like the splitting causes minor reorganization. So at any time when you split a particular bucket, you don't have to disturb other buckets. Simply you will do some adjustment between that bucket and the newly allocated bucket. So only minor reorganization is needed whenever there is splitting. Okay, so that is also one benefit. But in our normal static hashing, if you want to insert something in between, definitely it is going to reorganize everything else. Okay, the only time and this is when the only situation where this reorganization is going to be expensive is when you want to double the directory or half the directory, where there are many pointer adjustment you have to do in all of the, but that will happen very rarely. Only in all other situation it is going to work well. That about it. It's a relatively very important topic from this module, extendable hashing. So you just have to explain. So that is only expected from the dynamic hashing technique, but there are other techniques also that can do this dynamic hashing. Some variations there are there that you can read if you are interested. Yeah, thanks for watching.